Right. Good morning. So today we'll discuss some important problems in permutations and combinations. Okay. So we'll continue from that. A fruit basket contains 4 oranges, 5 apples, and 6 mangoes. The number of ways a person makes a selection of fruits from the basket is your first option 210, the second option 209, the third option 208, and the fourth option none of these. Here, a fruit basket contains 4 oranges and 5 apples and 6 mangoes. Here, 3 types of fruits we have in that basket, right? So here, we are going to find total number of selections a person made from that basket. Okay. So, for example, in other case, if we have one mango, one apple, one orange, and one pineapple. Let us say there are 4 different types of fruits. Then how many selections can be made from this? Okay. So here, number of selections out of these 4 fruits can be done in 2 power 4 ways. Okay. So 2 power 4 is nothing but out of 4 fruits, he may select 0 number of things. He may select any one of those fruits. He may select any 2 of those fruits. He may select any 3 of, and he may select all the fruits. Okay, so when you have 4 different things, okay, when you have 4 different fruits or 4 different things, how many ways a person can select from those 4 different things? Is 2 power 4. So, for example, that means when we have n different things, number of selections made is 2 power n. 2 power n means nc0 plus nc1 plus nc2 so on ncn. Okay, so this is the formula for number of selections of n things 2 power n. Okay, so now in the same way, when we have categories of things, for example, so 3 mangoes and 4 apples and 5 oranges are there. Imagine. So then number of ways will be p plus 1 q plus 1 into r plus 1. Okay. So when you have categories of things, formula will be p plus 1 into q plus 1 into r plus 1. Means p means number of things of first kind, as there are 3 mangoes. Q means number of things of second kind, as there are 4 apples. R means number of things of third kind, as there are 5 oranges. Okay. So number of selections can be made when we are given categories of things is p plus 1 into q plus 1 into r plus 1, which is different from this formula. Here when you have n different things, formula is 2 power n. When you have categories of things, this will be the formula. In that also, number of selections of one or more. See, means selection of at least one fruit compulsory. Then, for this reason, we'll write minus 1. So, same thing we are going to use in this case. Okay, here we have given four things are alike of first kind, 5 things are alike of second kind, and 6 things are alike of third kind. When you are given categories of things, then total number of selections will be p plus 1 into q plus 1 into r plus 1 minus 1. So why do you write minus 1 here? So at least one fruit must be selected. Okay. So without one, so total number of selections will be p plus 1, q plus 1, r plus 1. Okay. We have to select at least one fruit, means minus 1. That case we eliminate where we are not taking zero number of fruits. Okay. So this is the formula we'll be going to use in this question. Okay. It's very simple. Now let us use this formula now. Here, how many oranges are there? 4. How many apples are there? 5. How many mangoes are there? 6. Simply number of selections in this case, 4 plus 1 into 5 plus 1 into 6 plus 1 minus 1. Okay, so 5 into 6 into 7 minus 1. Okay, 210 minus 1, which gives us 209. This is total number of selections when you are given 3 different categories of things. Clear? So which option will be correct here? Option? Yes, B. Make a note of that. Clear? So let us move on to next one. Now, the number of ways, the number of ways in which five boys and three girls, five boys and three girls be seated, be seated in a row so that each girl is between two boys. Is. So first option 2880. The second option 1880. And third option 3800. And the fourth option 2800. Just try to understand this question first. The number of ways in which five boys and three girls be seated in a row so that each girl is between two boys. Okay? It's very simple. So we need to arrange boys first. In those gaps, we are going to arrange the given number of girls. Okay? It's very simple. First of all, how many ways we arrange the boys? 5 factorial. Correct? So when you arrange 5 boys, how many gaps left in between boys? 4. Okay? In those 4 gaps, we are going to select remaining 3 girls, which can be done in 4p3 ways. That's it. So answer will be 5 factorial into 4p3. Clear? Now let us solve. First of all, we need to arrange 5 boys in a row. Okay? So how many ways we arrange 5 boys in a row? 5 factorial ways. Okay? So we can arrange 5 boys in 5 factorial ways. Okay? So when you arrange 5 boys, how many gaps left? Generally 6 gaps. Okay? When you arrange 5 members, 6 gaps left. When you arrange 6 members, 7 gaps left. See here. Here 5 boys have arranged. How many gaps left? Obviously 6 gaps left, including extreme places. 1, 2, 3, 4, 5, 6. 6 gaps left. Okay. But here the question is given, each girl is between two boys. Okay. So between two boys, how many gaps are there? In those gaps, we need to put these girls. Okay. So we should not consider extreme gaps. Okay. Now, so how many gaps left in between boys? 4. In those 4 gaps, we are going to arrange these 3 girls so that each girl definitely in between 2 boys. Okay. So in these 4 gaps, we are going to arrange remaining 3 girls. Okay. In these 4 gaps, we are going to arrange these 3 girls. Right? 4p3. So what is the answer now? First, number of boys can be arranged in 5 factorial ways, and in those 4 gaps in between boys, 3 girls can be arranged in 4p3 ways. Therefore, total number of ways 5 factorial into 4p3. So 5 factorial means 120, 4p3 24. So what do we get? 2880. So, which option will be correct here? Option A. Clear? Make a note of that. Clear? So we'll go for next problem. Now, the number of words that can be formed out of the letters of the word, out of the letters of the word, article, so that vowels occupy at even places is first option 574, the second option 36, and third option 754, fourth option 144. Just try to understand the question here. The number of words that can be formed out of the letters of the word, article, right? So that vowels occupy even places. So first of all, how many letter word given here? 1, 2, 3, 4, 5, 6, 7. Okay. First of all, let us take 7 gaps. 1, 2, 3, 4, 5, 6, 7. Okay. So now we know that all are different letters. Okay. So there is no repetition in that word article. Right. No letter is repeated. So that vowels occupy at even places. In 7-letter word, how many even places we find? So 1, 2, 3. Second place, fourth place, sixth place. These three are even places. In these even places, we need to arrange vowels. How many vowels are available here? Out of this word, A, R, T, I, C, L, E. In this, what are vowels here? A, I, E. So in these three even places, three vowels can be occupied in 3 ways. Okay? In 3 places, 3 vowels can be arranged. Okay? A, I, E can be arranged in 3 ways or 3 factorial ways. Okay? 3 factorial ways. Now, how many gaps left? 4 odd gaps for remaining 4 consonants. Correct or not? So, 4 odd gaps left for remaining 4 consonants. In those 4 odd gaps, 4 remaining consonants can be arranged in 4p4 ways. Okay? So, now the remaining 4 odd gaps, remaining 4 consonants can be arranged in 4p4 ways. Therefore, total number of ways. Okay? So, total number of ways equals to 3p3 into 4p4. 3p3 means 3 factorial, 4p4 means 4 factorial. 3 factorial into 4 factorial, which means 6 into 24 is 144. Clear? Simple. Here we have 7-letter words, 7 gaps. In 7-letter word, there are 3 even gaps. In those 3 even gaps, we are putting 3 vowels. That can be done in 3p3 ways. And remaining 4 odd gaps can be occupied by remaining 4 consonants. So in those 4 odd gaps, 4 consonants, 3 even gaps, 3 vowels in their respective places can be arranged in 3p3 into 4p4. Direct answer, so 144. Clear? So which option will be correct here? Option D. Clear? Make a note of that. Clear? So we'll go for next one. Now let Tn denotes the number of triangles, the number of triangles, the number of triangles which can be formed, which can be formed by using vertices of a regular polygon, a regular polygon of n sides, of n sides. Okay, if Tn plus 1 minus Tn equals to 21, then n equals to, okay, so it's very easy, just we'll take the option there, 5, 7, 6 and 4. See here, a direct question, Tn denotes the number of triangles which can be formed by using vertices of a regular polygon of n sides. Okay, so n sides means n vertices. Okay, now, so here, so what is the formula for number of triangles? Number of triangles by joining n different vertices. Okay, so number of triangles formula. First of all, we'll take formula for number of triangles. Number of triangles formed by joining n points. By joining n points or n vertices is simply nc3. Okay, so this is the formula which we have to understand here. Number of triangles formed by joining n vertices is nc3. Okay, here Tn plus 1 means number of triangles formed by joining n plus 1 number of points. What do you mean by Tn? Number of triangles formed by joining n vertices. Okay, now Tn plus 1 means number of triangles formed by joining n plus 1 points, which is nothing but n plus 1 C3. Tn means nc3. So what was given condition here? Tn plus 1 minus Tn equals to 21. Right? Tn plus 1 means number of triangles formed by joining n plus 1 points. N plus 1 points means form like n plus 1 C3. If it is n points, n C3. N plus 1 points, n plus 1 C3 we can write. For this, n plus 1 C3 minus n C3 equals 21. Okay? So from this directly we can verify the options. Otherwise, we can simplify this. Okay? So we know this formula, NCR plus NCR minus 1 equals to n plus 1 CR. Okay? NCR plus NCR minus 1 equal to n plus 1 CR we can write. The same way, we can write the same formula in reverse manner. N plus 1 CR can also be written as NCR plus NCR minus 1 less than this. So how can I write this now? N plus 1 C3 means N C3 plus N C2 1 less than this. Clear? So from this I can write this formula. So that NC3 get cancelled there, right? So finally, NC2 equals to 21. Okay, just we can verify there with the options. Okay, so which option will be correct here? Yes, 5C2, 21? No, 10. 5 into 4 by 2 into 1, 10. 7C2, 7 into 6 by 2 into 1. Yes, it gives us 21. Just by verification in the end. We no need to solve. Okay, generally for objective type, we should not waste our time by solving it completely. Okay, so in the end, just we can get the answer just from verifying the option there. So NC to 21, that means N must be 7. So which option will be correct here? B. Clear? Make note of that. Clear? So we'll go for next problem. Now, so we'll move on to next one. The number of ways of of distributing number of ways of distributing 8 identical balls, 8 identical balls in distinct boxes, three distinct boxes, so that none of the boxes is empty. None of the boxes is empty. Is. Okay. So now here first option 5, the second option 21, third option 3 power 8, and the fourth option 8C3. Okay. Now, first of all, read the question. The number of ways of distributing 8 identical balls. Okay. So here, if you are not given 8 identical balls, how many ways we place 8 balls in 3 boxes? Here we have to go through general case first. Okay. How many ways we place 8 balls in 3 boxes? Okay. For example, 8 balls are given. Okay, 8 different balls. Imagine here we are going to understand this concept by taking a general situation, right? So we are having uh, 8 different balls. How many ways we place 8 different balls in 3 boxes? In 3 boxes. Okay, it's very easy. Just we discussed the previous session. Okay, one ball can be placed in any one of the boxes. So for every ball to place it, how many possible choices? 3 ways, right? So for every ball, we can place it in 3 ways. So like that, each of 8 balls, there are 3 ways. Okay, so that 3 into 3 into 3 into so on 8 times. we are going to write possible number of ways of placing it in those boxes for each and every ball. So that here we have 8 number of balls. For every ball, if you write possible number of ways as 3, so 3 8 times we need to multiply. So 3 for 8. Okay, so this is the answer for this general situation. So when you are given 8 different balls, how many ways we place 8 different balls in 3 boxes? Simply 3 for 8. Okay, but here 8 identical balls were given. Okay, so when you are given 8 identical balls, so we need to write possible number of number we can give, we can distribute that to each of these boxes. Okay, we'll see now. Here 8 identical balls are given. Okay, now 8 identical balls given. So these balls are same. Now we are going to distribute these in these 3 boxes. In how many ways we can place, we'll see. See, out of 8, so I may put here one ball, here one ball, here box 1, box 2 and box 3. Okay, so here now in first box I can put one ball, second box I can put one ball, third box I can put how many? Remaining 6. Okay, this is one way. And these can be shuffled. After that we'll arrange these. Okay, because here one ball, here one ball, here 6 balls. Here 6 balls, here one ball, here one ball. Okay, and the same way 1, 1, 6. So like that we'll arrange in the end. Okay, first of all we need to list out what are the possible number of numbers we can distribute these 8 balls in those 3 boxes. Okay, here 1, 1, 6. Now here we can put 2 balls. Here one ball suppose. Here how many remain? 5. Okay. And more. Here one ball. Here 3 balls. 4. Remaining 4. 1, 3, 4. Okay. Now more. Here 2 balls. Here 2 balls. 4 plus 4. 2, 2, 4. So 2, 2, 4. Okay, more. Okay, 5. Okay, next up. Yes, 3, 3, 6 plus 2, 8. So 3, 3, 2. That's it. Anything more? No. Right? So, in these ways we can place. Here one ball, 6 balls. 2 balls, 1 ball, 5 balls. Okay? 1, 3, 4 like that. Okay? So, these can be shuffled. 1, 1, 6. Same 1, 1, 6 can also be written as 6, 1, 1 or 1, 6, 1. So, how many ways we arrange this? 3 factorial by these two are same by 2 factorial. And these 3 can be arranged in 3 factorial. And these 3 can be arranged in 3 factorial. And these 3 can be arranged in, yes, 3 factorial by 2 factorial. These two are repeated, right? So 3 factorial by 2 factorial. Here, same. These two are repeated. 3 factorial by 2 factorial. That's it. So what is total number of ways now? Here 3 factorial by 2, 6 by 2, 3. 3 plus, here 3 factorial 6. Here 3 factorial again 6. Here 3. Here 3 again. So total how many ways? 6, 12, 18 plus 3. How many? Yes, 21. Okay, the total number of ways is 21 here. Understood? Here we need to place in different numbers. In different ways we will distribute those number of 8 balls in 3 boxes. So finally those can be shuffled, okay, in different boxes. Okay, here 1 ball, 6 ball. That can be shuffled 6-1-1 or 1-6-1, like that, in 3 ways. Okay, here 2-1-5, 2-1-5 can also be written as 5-1-2. Here 1, here 2-5, here 1-5-2, 2-5-1 or 2-1-5, 5-2-1, like that. How many ways? 6 ways. If I have 3 numbers, 3 digits, then we can arrange them in 3 factor ways. If anything is repeated, we'll write down. That we know. Okay? So like this, we can find total number of ways. But what is shortcut for this mode? Okay? So to list out like this, it takes time for MCQs. Right? Now, so when you are given n identical balls and r distinct box, formula will be n minus 1 c r minus 1. So this is the shortcut for this model. Okay, n minus 1 c r minus 1. But this is for your understanding. Okay, this is for the concept, right? So directly we can go for applying this formula in the exam. N minus 1 c r minus 1. So n means 8, r 3. So n minus 1 7, r minus 1 2. Simply 7 c 2. 7 c 2 is nothing but 21. That's it. Okay. Now, okay, 7 c 2. Clear? Take note of that. This is the concept and this is the shortcut, right? Clear? So we'll go for next problem. Now, so we'll go for next problem. We'll move on to next one. NCR plus 2 times of NCR plus 1 plus NCR plus 2. is equals to. Okay, so here first option is 2 times of NCR plus 2, N plus 1 CR plus 1, N plus 2 CR plus 2, none of this. Okay, it's very easy here. NCR plus 2, NCR plus 1. Again, we use this formula. So, what was the known formula? NCR plus NC R plus 1 equals to here N. The result next number N plus 1. See, in these greater suffix will write. Greater suffix is R plus 1. Okay, so this is the formula which we use in this. Okay, so now here NCR plus 2 times of NCR plus 1. So let us take NCR plus 1 plus NCR plus 1 plus NCR plus 2. Okay, so now these two combined we can apply this formula. The same way these two combined we can apply the same formula, right? NCR plus NCR plus 1. So can I write N plus 1 C R plus 1. Correct? N. Next number N plus 1. Here greater suffix is R plus 1. In the similar manner, NCR plus 1, NCR plus 2. N. Next number N plus 1. See, R plus 1, R plus 2. What is greater suffix here? R plus 2. Yes, R plus 2. Now again these two comes under formula. N plus 1, N plus 1 same. Here R plus 1, R plus 2. These both are consecutive suffix. Okay. Now N plus 1, N plus 1. Its next number N plus 2. N plus 2. See, R plus 1, R plus 2. What is greater suffix? R plus 2. Okay. So which is the correct option there? Option C. Here, just go through this formula, right? Make a note of it. Clear? So we'll move on to next one. Now, the number of ways in which nine persons nine persons can be divided into three equal groups. Into three equal groups. Three equal groups is first option 1680. The second option 840. Third option 560. The fourth option 280. Okay. So we have discussed this concept yesterday. In the previous class we have discussed this one. Okay. The number of ways in which nine persons can be divided into equal groups. So once again we'll discuss that. So distribution of things into persons, distribution of things into groups. Okay. For example, how many ways 100 things can be divided into three groups? How many ways we divide or we distribute 100 things into three groups in 20, 30, 50? So like this distribution values will be given in the question. Okay. How many ways we will divide 100 things into three groups 20, 30, 50 respectively? So it's very simple. 100 factorial by these 20 category, one category, and these 30 comes under one category and 50 comes under one category. Like this will write. Okay. Similarly, these 100 things, how many ways we can divide 100 things into two equal groups? Two equal groups means each one will get 50. That we know. Okay. How many ways we divide 100 things into two equal groups? Here equal distribution. Here different distribution. But both are comes under dividing into groups only. Okay. Now, how many ways will divide 100 things into two equal groups? Means 100 factorial by 50 factorial, 50 factorial. So whenever one equality is there, one equal share is there, whenever there is an equal share, that factorial will write. So how many equal shares we have? Two. That 2 factorial will mention the denominator. Okay. So number of equal groups factorial will write down. Okay. So when you have equality, equal shares or equal parts, equal groups, how many equal groups? That number factorial will write it down. This 50 can be any way. Okay. First group, second group can be rearranged into factor. Okay. Now, third thing, how many ways we divide 100 things into three persons? Here we are going to distribute among persons. How many ways we distribute 100 things into among three persons? 20, 30, 50. So 100 factorial by 20 factorial, 30 factorial, 50 factorial into number of persons factorial will write. Okay. How many ways we distribute 100 things into three groups? Sorry, three persons. We are going to distribute 100 things into 100 things among three people. Okay. So 100 factorial by 20 factorial, 30 factorial, 50 factorial common. Okay. So now into number of persons factorial. Okay. So first division, then distribution. First 20, 30, 50. We have divided first. First division, then we are going to distribute 20 to any person, 30 to any person, 50 to third person. Okay. So those can be shuffled, those can be arranged in three factorial. So when the distribution is among number of persons, we need to mention number of persons factorial for the answer in the end. Okay. Now in the same way, how many ways we divide 100 things equally to two persons. Okay, two persons means 50 each. That we know. Okay, so as we know that each one can distribute in 50. Okay, so 100 factorial by 50 factorial, 50 factorial here common. Now, whenever equal part 1 2 factorial, number of persons into 2 factorial. Okay, so this will be right. So these are the distribution of things into groups, distribution of things among persons. Okay, so here also for this question, 9 persons divide into 3 equal groups in this category. 9 persons can be divided into 3 equal groups. So 9 factorial by each one will get 3. 3 factorial, 3 factorial, 3 factorial. Okay, so now, so 3 equal parts. So one more 3 factorial will write because these 3 are equal part. Okay, so 9 factorial by 3 factorial whole power 4. This can be calculated so that we will get answer. Okay, now clear? So option will be 2ID. Okay, we can calculate. Make a note of that.
Good morning. Today I am going to discuss few questions from gravitation. The questions I will detect, will write also. The gravitational force, acting on a particle due to solid sphere of uniform density and radius r at a distance 3r from the center of sphere is F1. A spherical hole of radius r by 2 is made the sphere with hole exerts a force F2 on the same particle. What is F1 by F2? It's a very important type of question. A gravitational force acting on a particle due to a sphere of uniform density. This is a sphere, so of uniform density. Its radius is r. We take this point, that is 3r. Here a particle is there, so it get a force of F1. Now they are given the same case, but we are making a hole here. The radius of the hole is r by 2. Same point I should find here. Particle of mass m is there. This distance will be there. From here to here it is 3r. So I should calculate what is the force exerted. And this is nothing but F2. So remember here, when it is made of uniform density and this particle and another mass, its force we can write it as, what is gravitational force equation? It is F1 is equal to G M capital M divided by distance is 3r the whole square. This again I can write G M into this density into volume. I can write 4 by 3 pi r cube divided by 9 r square. Equation number 1. Now, why I took it like this? Because we are removing a small portion. So here now the mass is not m. The mass is the remaining portion only. So what we should do now, we will calculate what is the force exerted by the portion of whole. The mass, the whole region, mass I should find out. Mass of the whole region. That is nothing but density into what will be the volume 4 by 3 pi r by 2 the whole cube will be the mass. Then only that whole region, what is the force exerted? Or I am just writing only the whole region, what is the force? That is G m into rho 4 by 3 pi into r by 2 the whole cubed divided by, can you tell the distance? We need the distance from this point to the center. So the total distance we know it is r. So this particle distance we can write it as 3r minus r by 2. Because the total radius will be r by 2 the whole square. I can take this as 4 by gm rho 4 by 3 pi r cubed into, here we will get an 8. This is 3r minus r by 2 is 5 by 2. So we can write this as 1 by 8 into, the down one I can write by 4 by 25. 4 by 25. The rest all will be same. This I can take it as equation number 2. But we need for the remaining portion, the remaining region. Remaining region means sphere with hole. Sphere with hole. If the sphere is with hole, rest all will be same. You see, this part will be same. Here also this part is same, this only. Other than that, what we are getting here, one denominator r square will be there. That is 1 by 9. This is nothing but, I can write here the remaining region as all the constant terms I am writing g, m, rho 4 by 3 pi r into 4 by 3 pi r into, the first one is 1 by 9 minus. Here I can write here, if you cancel these two, this is 1 by 50. So that is 4 by 3 pi r rho gm into, the LCM when you are taking, we are getting here, I can take it is 50 into 9, here I can write here 50 minus 9, that is 41. That is nothing but 41 by 50 into 9, equation number 3. The question is F1 by F2. This F remaining is nothing but your F2. So I can take this all you remember, I did not write a constant value. These full constants are here. So we can write F1 by F2 is nothing but, this 9 will be there, 9 will get cancelled, so it is 50 by 41. I will explain this question again. In this case, this question is, we have a particle and we have a solid sphere. This is your solid sphere and this is your particle. It is at a distance of 3r. So, due to this mass, we get a force here. That is simple G m1 m2 by r square. I wrote that. But here the problem is, the next sentence, they are given a small portion, we are taking it out. And it is of uniform density. So, I am just writing the mass in terms of density, nothing else. Mass is density into volume. Why I have taken this step in the first? Because in the next line they are given about taking out this. Next step. From here a small region like a hole we are taking it out. But the question is, what is the ratio force without hole and with hole? So I should find out that whole region mass, what is the force exerted here? What is the force exerted only due to the whole region? Whole region is only this hole and this one is coming. So I should take here what is the distance. So I am just taking here 3r will be there, this full region will be there. So if whole region GM rho divided by 3R minus R by 2 the whole square. So this part got the rest all the part because this full region I need. So here we know this is R by 2 means this also should be R by 2. That gone. The rest distance should be there between this mass and this mass. I am taking 3R minus R by 2 the whole square. That is only for the which region? Only pole I am taking separate. Rest all you are not taking, only the pole region. Then when you take this part also, you remember it should be coming like this, just half, almost like this only. Then we should find what is the mass of this region. That I use unitary method. Whole region mass is density into volume of this region. That is 4 by 3 pi R by 2 Q. I got it. Then after that, all the constant terms we are taking this side. Rest will be this 1 by 2 cube, 1 by 2. 3R minus this one will be 5 by R. 5 by R, this R square will be there. 5 square will be 25, 2 square will be 4. Okay. We need the remaining, now we remove that. After removing, we are getting the forces F1. So that I should subtract it. After subtracting, I get this. I got a value 41 by this constant value is there. Is all into this one. So I can write here. I will just. You can just write if you want this full term. Otherwise, you can get confused. F2 is equal to 4 by 3 pi R rho G M into 41 into 50 by 9. This is your F2. They are asking the ratio. When you take the ratio, you see these all, this full term is constant. Full term constant. This R square and R will be cancelled. Here will also be R. Rest will be only 1 by 3. That 9 will get cancelled with this 9. It will go up and we get it 50 by 9. Next. Very important question with the whole. We did this type of questions in rotatory motion also, and we make a call what happened for the center of mass, what happened for the moment of inertia. Next question. If Earth were to rotate about the axis, the weight of a person at equator is half of weight of a person at poles. I just cut shorted the question. This is the question. We should find what is the time period of rotation of the Earth. Weight of a person at equator, you can just write a question like this only, no problem. The weight of the person at equator is equal to half of the weight of the person near the poles. Then what is the time period? I give you what is the variation of gravity. Acceleration due to gravity, due to height, due to depth and due to rotation. Due to rotation, you should remember the variation of G. Variation of G due to rotation. Due to rotation, we can write it as G phi is equal to G minus R omega square cos square phi. Okay, so the weight of the person, the weight is G phi at equator is equal to half of m G phi of poles. M cancel. G phi you can write it as G minus R omega square cos square 0 minus half of G minus R omega square cos square 90. Cos square 90 0. G minus R omega square is equal to half of G. That is R omega square is equal to, what we are getting, half is getting, G by 2 will be there, G minus R omega square cos square phi we got, that will be equal to 0. That will come as G R omega square is, this will go that side, so we can write G minus G by 2. It will be equal to G by 2. Omega square is equal to G by 2R. Omega is equal to root over G by 2R. Time period is 2 pi by omega. That is 2 pi by, what is your omega equation? 2R by G. 2R by G. Very important question. Weight of a person at equator is half of the weight of the person near the poles. Then what is the time period? What is the time period they asked? All remember this one, variation of G due to rotation is G phi is equal to G minus R omega square cos square phi. A satellite mass M orbiting in a circular orbit of radius r around Earth of mass capital M. Find angular momentum. Angular momentum. Already we learned in the last chapter what is angular momentum. L is equal to mvr. Angular momentum, we have a relation, many relations we have for angular momentum. But here we can use angular momentum is L is mvr. Here M and R we don't have any problem, V we have the problem. How to find V? So I discussed, when a body is moving in a circular orbit of radius r, we should have centripetal force. I can write here the gravitational force is converted to centripetal force, that is G mm by r, they gave it as r square is mv square by r, v cancel, mm cancel, r cancel, v square is Gm by R, V equals root over Gm by R, that is M into root over Gm by R into R. One R will get cancelled, that is M into, answer is yes, root over Gm by R square. Again, if you want this also, they gave it inside the root, so we can write it as G small m square capital M into R. This also correct. Remember the question, a satellite of mass M orbiting in a circular orbit of radius R around the earth of mass M. Find angular momentum. Angular momentum L equals mvr. M into V root over Gm by R into R. We got it. Now here velocity how to calculate, or if you can remember orbital velocity equation, you can substitute that. Next question. A body projected vertically upwards. A body projected vertically upwards from the surface of Earth with a velocity equal to 3/4 of escape velocity. Find maximum height. This type of questions are very important for all the competitive exams. A body is projected vertically upward from the surface of Earth with a velocity equal to 3/4 of escape velocity. And we should find what is the maximum height it reached there. So assume this is our Earth, mass of Earth is m, the radius is r. Here, from here a body we are projecting. Assume that it is reached here. This height is h. I should calculate this height. All remember, in all the cases, law of conservation of energy is valid. So at surface, this is highest point. So I can write the total energy at surface, that should be equal to total energy at maximum height. Surface we have a potential energy plus kinetic energy. Maximum height we have only potential energy, because at maximum height velocity will be 0. Then potential energy here it is minus gm by r plus kinetic energy is dead roll with a velocity 1/4 of the escape velocity of the Earth. So we can write half into m into 3/4 of escape velocity of the Earth is 2 gm by r. Root over gm by r, but d square is there now. This is nothing but half m 3/4 into escape velocity square. C equal to maximum height means I can write gmm by r plus h. Gmm is common throughout. I can write here minus 1 by r plus 3, 2 will get cancelled. So we can write 3/4 r is equal to then so the answer I got it as h is equal to 3r. Somewhere we missed out. Sorry, here we did not do that. Here 3/4 of escape velocity. So here we should do it 9/16. So again we got it wrong here. So it should be 9 by 8. So here also we can write here 8R as the LCM. So it will be minus 8. Should be 9. So when you cross multiply, we will get here 1 equals when you cross multiply, we'll get 1 by 8R is equal to minus 1 by R plus H. Yes, it is 9R plus. Wait 1 minute. If you want one more step, I will write here. This step we should write. Wait once. We can minus. Here we squaring only getting the problem. We will write like that here. That will be better, I feel. Potential energy here it is minus G mm by R plus half m into V square is equal to, I am just writing all the steps now, G mm by R plus H minus G mm by R plus half m into, this is 3 by 4 of escape velocity, that is equal to minus G mm by R plus H. Steps will be increased, no problem. G mm by R plus half m into 3 by 4 into 3 by 4 square, if you will eliminate. So it will be, what will come? 9 by 16 2gm by R equals minus gm by R plus H. Now this 2 will get cancelled. I can again write here, my gm will get cancelled. Minus 1 by R is equal to, no, minus 1 by R plus 9 by 16 R is equal to minus 1 by R plus H. 1 by R plus H. So now we can just do it. 16R if you take the LCM. Minus 16 plus 9 equals minus 1 by R plus H. It is minus 7 by 16R is equal to 1 by R plus H minus 7R minus 7H is equal to 16R. We can even do one more thing here. One minus is there. This minus will get cancelled. So we can write here like this. So this again it will be 9R equals 7H or H equals 9R by 7. Repeated. A body. This is our Earth. On the surface of the Earth, we have a satellite. From here, we are projecting the satellite here. When you project the satellite, when it reaches here, we get, when it reaches at this point, the body has only potential energy. At this point, it has both potential energy and kinetic energy. So what I did, potential energy plus kinetic energy at the first point, that should be equal to potential energy at the highest point. Next, what is the potential energy at the surface? Minus gm by R. What is the kinetic energy? Half m v square. Here only we should remember v square. What is v they gave? 3 by 4 of escape velocity. So I should write here separately 3 by 4 of v square. 3 by 4 square we should do, even 3 by 4 also square should be there. So it should be 9 by 16. 2gm by r minus gmm by r plus h. Then throughout minus gmm I get I cancel 1 by r. We got it. Take LCM. After taking LCM, you get the value of it. 9r divided by 7. Next. Question you listen. A launching vehicle carries an artificial satellite of mass smaller around Earth of mass m radius r. If the satellite is intended to move in a circular orbit of radius 7r, what is the minimum energy required for this? What is the minimum energy required for this? Now you see, this question we should find a launching vehicle is there, artificial satellite is there. We have to calculate what is the energy required for this. Same like previous question, we will write this is the Earth mass, this is R. From here it is moving to which point? This point. What is the energy we require for this? What is the kinetic energy? Actually, they meant what is the kinetic energy required for this. At this point, it has both, it is revolving, so it has both potential energy and kinetic energy. Is at a distance of 7r. Here also we can use the law of conservation of energy. From here, what is the energy required? So I can write here also total energy should be first point that should be equal to total energy at the height. That is potential energy plus kinetic energy, that should be equal to potential energy plus kinetic energy here. So kinetic energy 1 is potential energy 2 plus kinetic energy 2 minus potential energy of 1. Can you tell me what is the potential energy here? This now we know the equation as minus G mm by R plus H. But they gave it directly the value as 7R, so we can do it as 7R, no problem. Because they told it's from the center of the earth only, so it is 7R plus kinetic energy. We know that half m into orbital velocity. What is orbital velocity equation? Gm by R. This also Gm by 7R. Gm by 7R minus this I can write Gmm by R. We have to solve it. Here one more thing is there, Gmm minus of minus will come. If you take the LCM will be 14R. This will be minus 2G. We need not write all the times. We can take Gmm as common means this will be minus 2. This will be 1. This will be plus 14. So it will come as 13. Yes, very important question, very important thing. What you should remember is a satellite is intending to move in a circular orbit of radius 7r around the Earth. What is the energy we should impart for the satellite to revolve in that orbit? For that, I have taken two concepts here. At the surface, we have the potential energy. Even we have to provide some kinetic energy to move out. That is the energy we should supply. Then, when it reaches at an orbit of 7r and they told that point it is revolving, that's why I took both potential energy and kinetic energy. Then, potential energy at this point minus Gmm by 7r. Kinetic energy we can write half m into Gm by 7r. Minus of minus Gmm by r. We solved it as we got 13 by 14 Gmm by r. Next. Next question. Time period of Jupiter is 12 times of time period of Earth. The distance of Jupiter is n times of distance of Earth. It's all around the sun. What is n? Question is, time period of Jupiter around the sun. These all are Jupiter around the sun and Earth around the sun. Like this. This is your sun, Earth, Jupiter. Okay. This distance they are given n times of Re. This time is Re. So we need the relation between the time period and the rotation. We know Kepler's third law, T square proportional to R cube. So it is T Jupiter by T Earth is equal to radius of Jupiter by radius of Earth whole to the power of 3 by 2. Now the thing is simple, they are asking the value of n only. So we can write T Jupiter is 12 times of T Earth by T Earth is equal to Rj is n times of Re by Re, the whole to the power of 3 by 2. Re, Re, Te, Te cancel. 12 is equal to n to the power of 3 by 2. So we can write n is equal to 12 to the power of 2 by 2. So answer they are given correct only. Answer they are given it as cube root of 144. Listen here. They are given here the time period of the Earth and time period of the Jupiter. Time period of Jupiter is 12 times of time period of the Earth. Both are around the Sun. It's around the Sun. Radius of the Jupiter is n times that of Earth. What's the value? N they asked. So I use the Kepler's third law, T square proportional to R cube. So J by T Earth is equal to Rj by Re the whole to the power of 3 by 2. Then T Jupiter is 12 divided by TE by TE n Re by R to the power of 3 by 2. We have written here 12 n 12 to the power of 2 by 3. We got it as cube root of 144. Next question. They are given a body of mass m is raised from the surface to a height of nr. What is the magnitude of change in gravitational potential energy? I already told many times what is gravitational potential energy equation. Gravitational potential energy is minus gmm by r. Here, what is gravitational potential energy at the surface? That is minus gmm by r. What is gravitational potential energy at the height? Which height they told? Is raised from surface to a height of nr they told. To a height of nr. Here, right. They are given here the height of nr. It means this is your earth and this height they are given. This is nr they told. But I need the distance from center to this point. So I can write minus gmm by r plus nr. I need the change of this. So change in potential energy is minus gmm by r plus nr minus of minus gmm by r. If you take it as minus gmm by r, take it common, it is 1 by r plus nr, or take r also common. So we can write it as 1 plus n minus plus 1 minus gmm by r into n plus 1, 1 plus, here it will be minus 1 cancel, minus gmm by r into minus n by n plus 1. This is correct, but in option this is not there in terms of small g. So we can write here what is gm. The small g is nothing but gm by r square. So gm by r I can write it as gr. So this equation only they gave mgr into n by n plus 1. Even this question also many exams they ask. What is the question? What if a body we want to change from the surface of the earth to a height of nr? So this is surface, this is height nr. In this question, remember, they mentioned here height of nr. So the distance from the center is r plus nr. So I can write here gravitational potential energy is minus gm by r. Surface is gm by capital R. Height is gm by r plus nr. Because r plus h is your equation. By r plus nr? Because denominator should be capital R plus h. Change I subtracted. Rest all it's same only. This option is correct, but this is not there. So that's what I converted capital G in terms of small g. One more question. GH is 9 meter per second. GH is equal to 9 meter per second square. G at surface is equal to 10. G at a depth of same H. What is the value they asked? What's the question? They gave H equation, H value they gave, surface value they gave, but they are asking what is the height you are taking, the same depth you take. For example, I can just make it like this, surface is 10, this point it is 9, what is this? What is this H? Same H should be here. What is the value here? That's the question. GH, we all know it is G into 1 minus 2H by R. 1 minus 2H by R. G depth, you know that G into 1 minus D by R. According to the first equation, equation number 1, if you write the first equation, I can write 9 equals 10 into 1 minus 2H by R. That is 0.9 equals 1 minus 2H by R. 2H by R is equal to 0.1 or H is equal to 0.1 by 2 into R. Equation number 2. Very simple only. If you want G depth, substitute the value. What is G depth? G depth is G into 1 minus D. D should be equal to H, they gave it in the question. 0.1 by 2 into R by R. That is 10 into 1 minus 0.1 by 2. What's the answer here? and 0.5 meter per second square. Remember the question, I have written all the equation, variation of G due to height, variation of G due to depth. Variation of G due to height is G into 1 minus 2h by r, and the variation of the depth is GD is equal to G into 1 minus d by r. These two relations you remember. They gave height equation, I just written the height equation, I got h and I just substituted d equal to h condition they gave it in the question, I substituted. Solve the questions from your textbook. Thank you.
So today I am going to discuss a few concepts of stoichiometry along with some problems. So mainly mole concept. As you know, the formula number of mole is equal to weight by gram atomic weight. Number of mole equal to weight by gram molecular mass. Number of mole equal to volume in liter by 22.4 liter per mole. For gases at acidity, number of mole equal to total particle by Avogadro number. This is valid for ions, atoms, molecules, etc. One more formula is there. If volume is not given in liter, then you can use number of mole equal to volume in milliliter upon 22400 ml per mole. Similarly, if you are asked number of atoms, you can write mole into Avogadro number. Number of ions, mole into Avogadro number. Number of molecules, mole into Avogadro number. Number of atoms from molecules. Equal to atomicity into mole into Avogadro number. So these are the formula that you have to keep in mind before attempting or solving any questions of mole concept. So let's start with few questions. Question number 6 of page number 2. Exercise 2 of your IIT material, question number 6. The density of water is 1 gram per ml. So density of water they have given 1 gram per ml. The volume of water drop is 1.8 ml. They are asking the number of molecules present in one drop. So number of molecules they are asking. Number of molecules. So first mass we have to find. So mass equal to density into volume. So density is 1 gram per ml into 1.8 ml. So ml will cancel. So it is 1.8 gram. So the amount of water is there, that is 1.8 gram. Now we have to find mole. So number of mole is weight by gram molecular mass. So 1.8 and the gram molecular mass of water is also 1.8. So 1.8 gram per mole. So it is what? It is 18. So it is 0.1 mole. So the amount of water present in 1.8 gram is 0.1 mole. So number of molecules. Number of molecules is equal to 0.1 into Avogadro number. That is 6.022 into 10 to the power 22. So this is the correct. So the answer is 4. So question number 6, answer is 4. Question number 7. Question number 7 says, increasing order of number of moles of this species. First, they have given 3 gram of nitric oxide. Second, they have given 8.5 gram of phosphine, PS3. Third, they have given 8 gram of methane CH4. So this is 14 and this is 16, so it is 30. So number of mole is 3 by 30, that is 0.1. Second, this is 31 and this is 3, so this is 34. So number of mole is 8.5 by 34. So this is 0.25 mole. Similarly for methane, it is 12 plus 4, that is 16. The number of mole is 8 by 16, that is 0.5. So they are asking increasing order of number of moles, increasing order. So we have to write the least first. So first, then second, then third. So your correct option is 1. So question number 7, correct option is 1. Question number 9. Question number 9. How many moles of magnesium phosphate Mg3PO4 will contain 0.25 mole of oxygen atom. 0.25 mole of oxygen atom. Suppose if we take 1 mole of magnesium phosphate, 1 mole, we have 8 moles of oxygen atom. If we have 1 mole of magnesium phosphate, we have 8 moles of oxygen. They are asking to have 1 by 4. Suppose, so 8 moles are present in 1 mole magnesium phosphate. So 1 mole is present in 1 by 8. So 1 by 4 mole is present in 1 by 8 into 1 by 4. That is 1 by 32. So 1 by 32 means we can write this into 10 to the power 2. So you can write 3 into 10 to the power minus 2. So your answer is 3.125. 3.125 into 10 to the power. So one is the correct option for question number 9. Question number 11. Number of electrons present in 1.8 gram of water. So number of electron equal to number of electron in one molecule into mole into Avogadro number. So number of electron in one molecule is 2 plus 8, that is 10. Mole is 1.8 upon 18 into Avogadro number 6.022 into 10 to the power 23. So it is equal to 6.022 into 10 to the power 23. So the number of electrons present in 1.8 gram of water is equal to Avogadro number. So the correct choice for question number 11 is 1. Question number 39. The number of molecules of CO2. So they are asking number of CO2 molecules which is liberated when there is a complete combustion of 0.1 gram atom of carbon. So graphite. So graphite reacts with oxygen to give CO2. So it is 0.1 gram atom. Suppose if we take 1 gram atom, 1 gram atom is 1 mole. So 1 gram atom reacts with to give 1 mole of CO2, that means I have a number of CO2 molecules. So 0.1 gram will give 0.1 gram molecule of CO2, that is 0.1 into Avogadro number. So this is 6.022 into 10 to the power 22. So the correct choice for question number is third. So 39, third is the correct choice. Question number 42. Mole fraction of C3H5OH whole thrice in a solution with 46 gram of glycerine and 36 gram of water. So we have a sample of 46 gram glycerine. So first we have to find the molecular mass of glycerine. That is 82. It is 92. So the molar mass of glycerine is 92. So number of moles of glycerine is 46 upon 92, that is 0.5 mole. Similarly, number of mole of water is 36 by 18, that is 2 mole. So total mole is 2.5 mole. So mole fraction of glycerine is equal to mole of glycerine by mole of glycerine plus mole of water. So it is 0.5 upon 0.5 plus 2, that is 0.5 by 2.5, that is 1 by 5, that is 0.2. So mole fraction of glycerine is 0.2. So answer is third. Third is the correct answer for 42 numbers. Question number 43. The volume of water to be added to 400 ml. 400 ml volume is V1 and normality N1 is N by 8 SCL. Volume 2 is we don't know, N2 is N by 12. So we know that N1 V1 equal to N2 V2. So N1 is N by 8 into volume is 400 ml. N2 is 1 by 12 and 10 by 12. V2 we don't know. So 12 into 400 upon 8, this is V2. So it is 50. It's 3. So it is 200, 3600. 3600. So volume to be added is delta V equal to V2 minus V1. That is 600 minus 400. So 200 ml volume has to be added. So the correct option for this is third. The density of 3 molar solution of NaCl. 3 molar solution of NaCl. 3 molar means number of mole is 3 mole and volume is 1 liter. So 3 moles of NaCl is dissolved in 1 liter. So we get 3 molar solution. And the density is given. Density is 1.25 gram per ml. So what is the molality? So we have to find molality. So for molality we need mass of solvent, weight of solvent. So volume is 1000 ml. So mass is equal to density into volume. So mass of the solution is 1250 grams. So mass of solvent equal to 1250 minus 3 into 58.5. This is the mass of solute. So it comes so 1250 minus 175.5. So if we subtract 175.5 from 250, so 1250 175.5. So it is 1074.5 gram. So molality is equal to number of moles. So 3 moles are there by into 1000 by weight of solvent in kg. So solving this will give you the molality. So 3000 by 1074. So the answer is 2.79 molar. 2.79 molar. So answer is one number. That is I 1.